1 to 5.
Right here it says, what is factoring? We should all know from Algebra 1 that it's like reverse distributed property. It's like doing distributed property but backwards, where you have the answer and you want to find the question, right? So if we take a look at this example right here, I'm zooming in so we don't see the actual answer. What I need to do is put some parentheses and then ask myself, is there anything in common? There's two terms here. Is there anything in common in this first term and the second term? The answer is yes. We want to pull out what's in common, but not only that, you want to pull out the greatest common factor, the GCF. So when we look at the numbers 2 and 6, what's in common?
3. No. 2.
2, right? There's a 2 that I could pull out. So I'm definitely going to pull out the number 2. But in addition to that, I also have an x in my first term and x's in my second term. So what's the maximum amount of x's I could pull out of both terms?
7.
Okay, I could pull out 7 from here, but could I pull out 7 from over here?
No.
Okay, so what's the GCF, the greatest? Yeah, 2. So I'm going to pull out not just the number 2, but I'm also going to pull out an x squared. So this is the first question you'll see on the test next week. What is the GCF? The GCF is right here, 2x squared. What is GCF? It's the greatest common factor. Yeah, so we just went through it. We said what's in common? Well, there's a number 2, the multiple of 2, and there's also x's, a maximum of 2 that I could pull out of both. So the GCF of the whole thing is 2x squared. Now, this is where we kind of say that factoring is a reverse distributed property. Because if I were to distribute 2x squared times what will give me a 2x to the 7th. And you could look at this a piece at a time, like the number 2 times what number will give me the number 2? 1. So you could put a 1 if you want. You don't have to, but I'll just put the 1 there. How about x squared times what will give me that x to the 7th? And remember, when you multiply x's, you really end up adding the exponents. So x squared times how many more x's to get to x to the 7th? 5, that's right. So I really have a 1x to the 5th on the first part of my binomial in the parentheses. How about the second one? 2 times what will give us a negative 6?
3.
A negative 3, so put a minus 3. And then x squared times what will give me an x squared?
3.
I don't want to mess with it. So if I must multiply, it's going to be a times 1. But I'm not even going to put the times 1 because that's totally pointless. We know that 3 times 1 is 3. So I'm not going to put that at all. I'm just going to leave it like that. You cannot put an x right here. Why not? Because x squared times another x would change it to x to the 3rd. You want it to stay the same, so don't even put anything. Make sense? Okay. That's what we call pulling out the GCF. Let's continue practicing. Let's look at number 1 right here. Again, we have 3 terms here, not 2. We have 3. I want to put parentheses right here. And I want to look at all 3 terms. And we could do one piece of it at a time, like the number 4, the number 6, the number 8. What's in common? 2. Okay, so let's pull out a 2 again. And then how about x's? I have x's in all 3 terms, so what's the maximum amount of x's I could pull out from all 3 terms at the same exact time?
0.
Okay, let me ask you this. Could I pull out 3 from the 5?
Yeah.
Could I pull out 3 from 2?
No.
Okay, so that didn't work. 1 is the greatest. 1 is the greatest. Right? What's the greatest amount of x's you can pull out from here, here, and here, all at the same time? It's just 1. So technically our GCF here out of this trinomial is just 2x. Now if I did pull out the GCF, what would be left over on the inside? And let's try to work on this together. Like 2x times what will give me a 4x to the 5th? 2x to the 4th. Because remember, you add them when you really multiply. Add exponents when you really multiply. How about the middle term? 2x times what will give us the negative 6x to the 2nd? Negative 3x. That's it, right?
Yeah.
Okay, and then how about 2x times what will give us a negative 8x? Negative 4. No x's. And we factored. Cool, right? This is what we call pulling out the GCF. It's the first type of factoring you learn in Algebra 1. It's the first type of factoring you're supposed to always try, because it'll always make things easier if you're factoring. Pulling out the GCF first. And again, GCF stands for greatest common factor. Now, you got to be a little careful, because like if I look at the 12, the 6, and the 18, I might think, oh, I could pull out a 2. Yeah, that's a common factor, but it's not the greatest common factor. I could pull out a 3. 3 goes into 12, 3 goes in, but it's not the greatest common factor. 6, right? So 6 for sure is part of our GCF. But what about the x's? The maximum amount of x I could pull out is x to the third. So the GCF is 6x to the third. Okay? Now, yes, you could have pulled out a 2x to the third. You could have pulled out a 3x. I mean, all these other common factors, yes. But you want to go for the greatest common factor. Okay? And the GCF is 6x to the third. Okay, so 6x to the third times what gets us the 12x to the 12th? 2x to the 3 plus 9 is 12. There you go. 2x to the 9th. How about the middle term? Minus x to the 3. You could put a 1 right here if you want. Or not. I mean, whatever you want. You know what? I'm going to write it just for funsies. Whatever. There it is. And the last third term inside of the parenthesis, minus 3. Just 3. What do you think? You guys got it?
Yeah.
Excellent. Now, this is the first tool that we have in our factoring toolbox. Okay, let's go for the next tool. And I love this one. This one's one of my favorites. We've been dealing with standard form quadratic trinomials. We know that it's ax squared plus bx plus c. We know you can find the vertex by doing negative b over 2 times a and then plugging it back into x. All that fun stuff. We've graphed parabolas before. But right now, we're focusing in on these standard form quadratics when there is no number right here. When the a value is 1. If the a value is 1, you're not going to see a 5. You're not going to see a 3. You're just going to see x squared with no number right here. Right? So when your a value is 1, maybe you want to highlight this or underline this. When a is 1, you could use this format. X. Okay? When your a value is 1, you could use this format. Now, what do I mean by this? Or what do you do once you have that format? It says, what times what is the c value that if you combine together will give you the b value? Okay? And that's exactly what we're doing here. Check this out. Number 1. I know I'm kind of rushing through it. I apologize. The a value is 1. Because the a value is 1, because there's no number right there, I could jump right into this. There's my format, my factored form format. Now, why could I do this? Because I know that when I distribute, x times x is x squared. Yay? If I had a 5 right here, I couldn't set this up. If I had a 3, I couldn't set this up. If I had a 2, I couldn't set this up. Okay? But because there's no number right here, I could set this up. Beautiful. Now from there, you got to think what times what is your c value that if you combine together is your b value. And on the instructions, I say right here, make a list of the multiples. So down here, I want to think what times what is my c value, negative 12, that if I combine together is my b value, positive 1. Let's make a list. What times what is negative 12? Let's start with the number 1. And actually, since it's negative 12, let's start with negative 1. Negative 1 times 12 will give me a negative 12. How about negative 2? Times 6. Okay. How about negative 3? 4. How about, that's it, right? Those are the only 3 possible combos besides changing signs. Now, what do I mean by that? Like maybe instead of positive 1 times 12, instead of negative 1 times 12, it's a positive 1 times negative 12. Anyway, we have our list. Question is, which of these pair of numbers combines together to give me 1? When I say combines, I'm thinking of adding and subtracting. So what's 12 minus 1? 11. Is that an 11 right there? No. What's 6 take away 2? Is that a 4 right there? No. 4 take away 3? Is that a 1? Yes, that's the winner right there. This guy right here. So you just put that minus 3 right there, put the positive 4 right there, and voila, you have factored. That's it. So like I said, this is one of my favorite tools in factoring. When the a value is 1, just set up the parentheses, put the x's, and then just make a list. What times what is this guy? And then go through each of these and see which pair of numbers combines together to give you the b value. You put it right there, you're done, you factored it. Again, factoring is a reverse distributed property. right? So if, let's say you weren't too sure about this. Did I do this right? Did I factor this right? I don't feel right about it. You could, if you wanted to, distribute x times x, x squared. X times 4, 4x. Negative 3 times x, negative 3x. Negative 3 times positive 4, negative 12. When you combine the middle two terms, you'll get a positive 1x. You have an x squared in the front. You have a minus 12 right there. And voila, it takes you back to the original. So you've verified that you did it right. Make sense? Okay. Yeah, of course. We're going to do several problems. Right there, I just showed you how to double check it. If you factor it and you're not too sure, you're not confident, you could distribute, combine like terms, and see if it takes you back to the original. Because after all, factoring is distributed property backwards. Let's do another one. Check this out. Whoops, what happened there? Check this one out. This one's kind of weird because there is no bx term. The b value is 0. Now, because the a value is 1, again, I could think this. Set this up. And then you could think, what times what is your c value, negative 25, that if you combine together is your b value, which is 0 because there is no middle term. So even if I try to make a list, right, negative 1 times 25 or negative 5 times 5, there's only two options. Which pair of numbers combines together to give you the middle value, which is nothing? The negative 5 and the positive 5, right? So there's your combo, negative 5, positive 5. You have factored. Like I said, one of my favorite tools, when the a value is 1, set up the parentheses, x, make a list of this guy, thinking of the multiples, see which pair of numbers combines together to give you the middle value, b. Let's try another. This one's a little bit more entertaining. Once again, because the a value is 1, I could jump right into this. Again, if I had a 2 right here, I couldn't do this. If I had a 3, I couldn't do this. Because it's 1, I could set up x times x because I know x times x will give me that x squared. Anyway, let's make a list of the 32 because I want to think what times what is c that if I combine together is b. So let's make a list. 1 times what is 32? 1 times 32. How about 2? 2 times something? 18? 16. Yeah, you're right. How about 3? 3 times something?
3 times.
No. How about 4? 4 times something? 8. Okay. How about 5? 5 times something?
No.
6? No. 7? No. 8? You're back to 8 times 4, so you're good. So the only 3 options here are the first, second, and that. Yeah. So let's scratch this out. So yeah, which pair of numbers, when I combine 1 and 32, that gives me 33. That's not 33. Right here, 16 and 2, what is that? 18. But it's negative 18. Perfect. That's exactly what I want you guys to notice. This 2 and 16 gives me an 18, but I want a negative 18. Now, what does that mean? I have the right number. It's just the wrong sign, which means I have the right numbers right here. They're just the wrong signs. So all you got to do is change the signs. Make them both negative. Or whatever you have originally, just change the sign of both of them. Like if one was positive and one was negative, change it to negative and then positive. So let's now plug in these values, minus 2, minus 16, and we're done. We factored. If you wanted to double check it, it's really easy. Just distribute, combine like terms. You should end up with the original. So again, one of my favorite tools of factoring, when the a value is 1, you think what times what is the c value? Make a list. And then combine your numbers, see which one gives you that middle value. And of course, you want it to be the same exact value, negative 18. Because we had a positive 18, I had the right number, just the wrong sign. I have the right numbers, just the wrong signs. Change them both, and you'll be good to go. All right. So that's 2 tools so far in our toolbox. Sometimes you're working on something, and one tool doesn't cut it. You actually need both tools at the same time to fix whatever you're trying to fix. That's what I call completely factoring, or factoring completely. Check this out. On this example, we begin with our first tool, pull out the GCF. You look at 2x to the third, 2x squared, and minus 40x. The GCF is 2x. So you pull out the 2x from all 3 terms, and you have this left over on the inside. Now, some students would stop right there, and that would be incorrect, because on the inside, you now have a quadratic trinomial with the a value of 1, which means you could set up parenthesis, x, x. So it's using both tools at the same time, right? And of course, yeah, what times what is negative 20? That if you add together is 1. Make the list. Negative 1 times 20, negative 2 times 10, negative 3 doesn't work, negative 4 times 5, that's it. Which pair of numbers combines together to give you the middle value 1? Negative 4 and 5, that's why there's a negative 4 right there and a 5 right there. Cool?
Yeah.
Okay, so let's use both of those tools on this example right here where it says completely factor. What's my GCF?
3.
Okay, is it just 3 or do I have x's involved? 3x, is it just 3x or is it 3x to a certain power? 3x to the third, right? You want the GCF, the greatest common factor. Okay, so what's left over on the inside? X
2.
to the second power
Minus 7.
minus 7x
To the first power.
to the first power. I don't need to put to the first power. What else?
Plus
Plus 12. We factored. Yay, but there's more. Look at the inside. This blue quadratic trinomial now has the a value of 1, which means now I might be able to do that. Of course, let's not forget about the original GCF I pulled out, bring that down in front. But now let's think, what times what is the C value, 12, that if I combine together is a B value, negative 7. Let's make a list, all right? How could I get 12? 1 times 12. What else? 2 times 6? 3 times 4. And notice how I stay organized. I start with 1, and then 2, and then 3, 4, and I just keep going until I get through all the numbers that I can. Obviously, the next one, 4 times 3, are back to 3 times 4. So those are the only 3 ways of doing it. Which pair of numbers combines together to give me the middle value, and of course of the blue one, not the original, negative 7.
Negative 3 and negative 4.
There you go. This last one gives us a positive 7. We want a negative 7. We have the right numbers. We just have the wrong signs. So make it a negative 3 and a negative 4 and pop those in right here. Negative 3, negative 4, and we have factored completely. What do you think? Pretty easy? Okay, so we have 2 tools, and we know that we could use both of those tools together at the same time. Here is yet another term, or another tool in our toolbox. Oh man, so many tools. Yeah. More. This is the last one. Last tool we're talking about today. And right here we're going to factor perfect square trinomials and binomials. Now before we even get to this, do we know what a perfect square number is? 1 is a perfect square number. 4 is a perfect square number. 9 is a perfect square number. 16 is a perfect square number. 25, 36, 49, 64, 81, It goes on forever.
100.
Yeah, so if you're thinking, what the heck, where's he getting these numbers from? How does he know these perfect square numbers? 1 squared is 1. 2 squared is 4. 3 squared, 4 squared. 5 times 5, 6 times 6, 7 times 7, 8 times 8, right? Okay, so we need to be familiar with these perfect square numbers, because if we look at this guy right here, and I'm trying to factor it, I can't do this. Why not? Because it has a 4 out here in the front, so I can't do that. So let me erase that. You can't even pull out a GCF because the 4 and the 36, yeah, but the 81, that's not going to work. So we're stuck. Those 2 first tools, they don't work for us. We've got to use this new tool. Recognize that you have a perfect square term right here and a perfect square term right here. So if you do have a perfect square term and a perfect square term, take the square roots of those perfect square terms and plug them into your answer format. The square root of 4x squared is 2x. The square root of 81 is 9. So if you put a 2x and a 9 on both of those, then all you got to do is think of the signs. Now, in order for me to end up with a positive 81, it's either going to be positive 9 times positive 9 or negative 9 times negative 9. I can't have opposite signs because that would give me a negative 81. So they're either both positive or both negative. What do you think it's going to be? If you end up with a negative in the middle, it has to be both negative. Because if they were both positive, if everything's positive, there's no way a negative is going to magically pop out. Make sense? Yeah. So right here, you're going to have both of the signs being negative. And that's how you factor when you have a perfect square term in the front and a perfect square term in the back. Now, it's not always going to work. So it's important that we double check it. So let's double check it. 2x times 2x, it's 4x squared. 2x times negative 9, negative 18x. Negative 9 times 2x is another negative 18x. Negative 9 times negative 9 is positive 81. And you could see that when you combine the negative 18x with the negative 18x, you really will get that negative 36x. So we see that it does work. I know that I factored it right. Whoops. Let's try this one right here. You know what? Even before this one, you might have a perfect square term like 25x squared minus, let's say, 81. You don't even have 3 terms here. But you do have a perfect square term in the front and a perfect square term in the back. So what is the square root of 25? X squared?
5.
5 with an x. What's the square root of 81? 9. And then if you need it to be a negative 81 at the very end, it has to be one positive 9 and one negative 9. And that's the only way that the middle term will cancel out when you combine it, as if one's positive and one's negative. So it doesn't matter which one you put, negative or positive, positive or negative, whatever. That's how you would factor that one. Okay, I just wanted to explain that briefly. Let's go to the next one. Whoops, what the heck happened there? This next one, number 2. What do you guys say? Could somebody tell me what the factor form is of this quadratic trinomial that has an a value of 9? 3x and 2. 3x and 2. And yeah, the signs will both be positive. Now, let's say you're taking a test next Friday and I ask you to factor this and you don't see this. You might see it written like this.
Are you foreshadowing?
I'm just letting you know that when you have the same exact binomial written twice, it's really the binomial squared, right?
You can put both or just that?
Either one's totally fine.
Would
But
you put both would be correct?
both would be correct, yeah.
Okay.
All right, how about this one? Could I apply this tool of taking the square root?
I mean, yeah.
No.
Wait.
No. Why not? Because 8 is not a perfect square number.
You're right.
Okay, so what do? Quit?
NS.
Greatest common factor.
Greatest common factor, the first tool that we learned. What could I pull out?
It's
Could I pull out an 8? No, just a 2. That's it, just 2. No x's. But let's at least pull out the GCF of 2. Let's see what happens. What do I have left over on the inside? 4x squared minus, pull out a 2 from 18. What do you get? 9. Okay. Now, I did pull out the GCF of 2. What's left on the inside? I have a perfect square binomial, right? I have a perfect square term right here. I have a perfect square term right there. So the 2 that's on the outside is still going to be there. But let's do the square root of 4x squared. What do I get? 2x. And how about the square root of 9? Uh-huh. Yeah, and yeah, one's going to be a minus, one's going to be a plus. And there's your final factored form. And those are all the tools that we're going to be talking about today. Do we get it?
Yes.
Okay, now, the question is, why the heck would I want to change this to this? Why would I want to go backwards to get to the multiplication problem of this? I mean, this looks nicer than this. Because it's math. Okay, to answer that question, let's flip the page. Check it out, guys. The reason why we want to factor, which is really a reverse distributed property, it's kind of like having the answer on getting a multiplication problem. The reason why we want to do that is to be able to solve. Because when we end up with something times something equals 0, then the first something could be 0, and also the second something could be 0. This is the zero product property. This is the property of math is a truth. The truth about multiplying and getting a 0 as an answer. If you take any 2 numbers and multiply them and you get 0 as an answer, the first one could be 0 or the second one could be 0 or maybe both of them are 0. But one of them has to be a 0. That's the truth about multiplying 2 numbers and your answer being 0. Okay, zero product property. So why do I want to be able to do this backwards? Because check this out. If I told you to solve that equation right there, x squared plus 4x minus 12, normally to solve, what do? We get x by itself on one side, right? But right here it's like having 2 x's. Like, I mean, even if you got the 12 over there, what are you going to do with the x squared and what are you going to do with the x? There's 2 separate x's. You can't solve it. So the reason why we factor is we recognize, oh, the a value is 1. I could set up parenthesis, x, x. What times what is negative 12? That if I combine together is 4. You go through that process. You get 6 and negative 2. The reason why we factor is so we could end up with something times something equals 0. That means that that first something could be equal to 0, and the second something could be equal to 0. And then you have two simple equations that you could solve and get your two answers to immediately. Your answers will be x equals negative 6 and x equals positive 2. Does that make sense? And this is a heck of a lot faster. See, last week I did give you something like this, and I told you solve it, and you knew that the answers were the x-intercepts, right? And yeah, this has a pattern 1, 1, 2, 4, 3, 9. You could find the vertex by doing negative b over 2 times a. But the bottom line is, this is a lot faster. Oh, it crosses at negative 6. It crosses at 2. I already know my answers, right? So factoring, splitting, and solving is the key right here. And that's why we're here in the instructions. I recommend you guys to underline these three words: factor, split, solve. Factor, split, and solve. Why do we factor? To get the multiplication. Why do we want the multiplication? Because then you could split it. If it's equal to 0, you could split it and set them each equal to 0, and then you solve your two simple equations: factor, split, and solve. Let's do number 1 right here. Let's factor. Help me make the list. How could I get negative 24? Negative 1 times 24. What else?
Negative 2 times 12.
Okay, what else?
Negative 3 times 6. Negative 4 times 6.
And you can't. Okay, that's it, right? Which pair of numbers will combine, well, that multiplied to give us negative 24 combines together to give us 2? That's right. And we don't have to change any signs, right? Negative 4 plus 6 is positive 2. That's exactly what we want. So let's just plug them in just the way they are. Negative 4, positive 6. We factor to be able to get this equal to 0, to be able to split them and solve. So we have x minus 4, that could equal 0. X plus 6, that could equal 0. This is going to be on the test next Friday. So what are my two answers going to be? X equals 4. X equals negative 6. Yeah, pretty much. But I want you to understand the real process, that you set this equal to 0, set that equal to 0, and you solved both of them to get those two answers. We factored it, we split it, we solved it. Factor, split, and solve. How about that one?
That's the same.
It is the same. What do I do?
So it's the one where you have to 2.
What's my list?
It'd be 1 times 18, 2 times 9,
2 times 9,
3 times 6,
3 times 6,
That's it.
and that's it. Okay. Which pair of numbers work?
9.
2 and 9?
it has to be negative.
Has to be negative.
2 plus 9 gives us 11. That's great, but we want a negative 11. So yeah, change both signs. We have the right numbers, just the wrong signs. Change both signs. We now have a minus 2 right here, a minus 9 right there. The whole purpose of factoring is to get the multiplication of something times something that equals 0. That way that first something could be equal to 0, and the second something could also be equal to 0. Solving both of these, you get your two answers. What are your two answers? I didn't show my work, but I hope you guys understand. Add 2 to both sides, add 9 to both sides. Those are your answers. That's a heck of a lot faster than graphing a parabola and finding out those x-intercepts. What's the problem with this one?
It equals 36.
It equals 36, and we want it to equal 0. I mean, for us to use a 0 product property, we need it to be equal to 0. Yeah, so let's subtract 36. Subtract 36. We have x squared minus 5x minus 36 equals 0. And now, because the a value is 1, we could try to do this. And what times what is my c value of negative 36? Let's make a list.
1 times negative 1.
And 1 times 36, negative 2 times 18. By the way, if you ever get stuck on the multiplication, get a calculator and just go like 36 divided by negative 2. That'll give you the 18. Negative 3 times 12. Nope. Negative 6 times 6. Yeah. So these are all the possible combos besides changing the signs. And we know when to change the signs when we have the right number to the wrong signs. So if we start combining these, this gives me a 35. That's not a 35. Negative 4 and 9. That gives us a positive 5, right? This guy right here gives us a positive 5. And we want a negative 5. So change both of the signs. Make that a positive 4, make that a negative 9, and then you're good to go. Positive 4, negative 9, now you're good to go. Now you could split it. X plus 4 equals 0. X minus 9 equals 0. And I'll be honest with you, a lot of students are like, oh, I already know the answer. I already know the answer is negative 4 and positive 9. I recommend, since we're starting, let's just show all of our work, all right? It'll be safer. So when you subtract 4, you get x equals negative 4. Over here, plus 9, x equals 9. Those are your two answers.
So when you ask like a question, find the x intercepts, couldn't we just do this like way easier instead of like trying to graph it?
True.
Even if you show a graph, couldn't we just like do it like that?
True.
Then why don't we?
Oh, yeah, we're going to be building all kinds of, we're going to have all kinds of tools in our toolbox. And it's up to you to determine what's the best method. All right? Looking at this one, those are two perfect square terms. So I could square root each of these, plug them into my factored form format, and then split them and solve, right? So what is the square root of 4x squared? 2x. What's square root of 9? 3. And one has to be a minus, one has to be a plus. Doesn't matter which one's which as long as they're opposite signs. Now we could split them. 2x minus 3 equals 0. 2x plus 3 equals 0. We could add 3 there, add 3 there. We will have 2x equaling 3. Final step, divide by 2, divide by 2. My answer is x equals 3 halves. This is way better than graphing, because even if you graphed, it would cross at 1.5, right? Let's do the other one. Same deal, subtract 3, subtract 3. 2x equals negative 3. Divide by 2, and yes, the other answer is x equals negative 3 over 2. That's negative 1.5. That's your other answer. So, ladies and gentlemen, we have learned or reviewed, because technically we were supposed to already know this from Algebra 1. If you forgot, I hope you remembered, or I hope you understood it now, all these different tools that we have in our factoring toolbox. We will tomorrow continue with other methods. So if you want, go to the worksheet that's posted tomorrow and you could do a couple of those problems. Or you might just want to watch the video over again tonight so it'll really stick to your brain so we could get better at factoring. Final detail before I end, just because, like let's say I had x squared minus 8x minus 20, and I tell you factor it. Factor. X, and if you make a list, what times what is negative 20? That's negative 1 times 20, negative 2 times 10, negative 3 doesn't work, negative 4 times 5, and that's it. Okay. Oh, man. Yeah. Okay. Well, yeah, this would be the right combo. Man, I tried to pull up a non-factorable problem and I messed it up.
Change it to 9 or something. No, change it to 2.
Oh, I got one. Make it a positive 20. Okay. All right, so let me go back over here.
Yeah.
So just change the
What the heck?
Change the
There is
8
no
to 9.
non-factorable.
No, wait. No, this will work. I mean, this is what I wanted to show, right? When you think what times what is 20, if this would have been a positive 20, 1 times 20, 2 times 10, 3 doesn't work, 4 times 5. Which pair of numbers combines together to give you negative 8? None of them, right? This gives you 21. That doesn't work. This gives you 12. That doesn't work. This gives you 9. It doesn't work. Even if you change the signs, it'll give you a negative 12 or a negative 9. So right here, none of them work. This is where you would say not factorable. Now, what the heck does that mean? That you're not able to factor it. It's just you're not able to do it. And sometimes that's what happens, right?
Will we get those on?
Anyways, we're done.